All right. Okay, so here's our third little day of stuff. I think if you guys are someone who's been watching all of them or coming every day, you've basically seen like every kind of question, like at least topic that could show up. So here's one that's been showing up in the last like 2, I think, late exams. Things being one-to-one and onto. One person, you know what one-to-one means? Go ahead, Frida.
Does that mean that the y or x value no matter which one it is only 1?
Okay, so one-to-one is the horizontal line test, which means the y can't repeat. Okay, function is the x can't repeat. What about onto? Does anybody know what onto means? All the y's are used. Perfect. Good. Sorry. All y's are used. Great. It's in the red back there. Good enough. Okay. So when we look at our picture, this first one's the x, second one's like the y. So you guys want to see, make sure all the y's are used, but none of the y's are repeating. Anybody know which one it is? 2. Good job. Nice. Because you don't have any double arrows. Like this one, the 2 would repeat, so it can't be that one. Here, 1's not used, so it can't be that one. And this one's got the 2 being repeated, so it can't be that. It's got to be 2. Is that pretty good for you guys?
Yeah.
Okay. We haven't talked about this yet. Just finding the inverse of something. Anybody remember the first step to find the inverse?
Switch sides to y.
Good work. Exactly. Nice job. We want to switch x and y, then solve for y squared. Okay, so switch x and y. So where we see a y, we're going to write an x. Where we see an x, we're going to put a y. Okay. Now your job is to get y by itself. Minus 2, x minus 2 equals 13y, divided by 13, and that is it. So y equals x minus 2 all over 13. We haven't seen this a lot. It came up on one of the tests doing the inverse. One thing to be careful of is they want to be tricky. They might not say find the inverse. Does anybody know what the symbol for inverse is?
Isn't it like the equal sign, like a no? Isn't it like x
the -1. Good job. Right? Miranda, perfect. Yeah, if you guys saw something like that, that means inverse. Okay. So they ask you to find x to the -1, that means find the inverse of the function. It might be tricky. Okay. All right, good work with that one. Somewhere on your Regents exam, they're going to have you guys go from radicals to fractional exponents. I just don't know how it'll show up. So this is just one way that I think you guys could see it. So here you have a radical, and it's a 4th root. But if you look at all of your options, do you see any radicals left? No, and you can kind of pick out, all right, I have some fractional exponents. So that's kind of your clue that we're probably having to rewrite things. Right. So if I wanted to start this, I'm going to put what's under my radical in parentheses. These are the 4s. Okay. Now, when we rewrite this, where does the little index of 4 go? Bottom. Good. What's going to go on the top? 1. Super. Okay. I'll let you guys think about how to simplify this first, and I'll walk you through it. We'll go from there to it. I wish I had the open. I know how to forget it. Yeah. Okay, for you. I know. Yeah. You're very conservative. All right, so watch out when you guys bring your exponent through. When you have the big coefficient, make sure the exponent stays as an exponent on it. What's your rule when you have exponents to other exponents though? Multiply them. Yes, nice. So we have a to the, what's 6 times 1/4?
3 over 2.
3 over 2. Perfect. Okay. Then what about 4 times 1/4?
4.
Close. 1. Okay. Now, when we go to reduce this, make sure it's 16 caret 1/4, not 16 times 1/4. Okay, so 16 caret 1/4. Okay, 2. Perfect. So it should be 2 a to the 3/2 b. Choice 2. Alright. Here's the other way I thought that maybe you could see something like this show up. It kind of combines exponent rules, some radical rules. Like illustrate. Alright, did you guys all get a chance to think about it for a little bit? Okay. So if you guys have anything to a negative exponent, the first thing we want to do is make it positive. So where does it need to go? Bottom. Good. This whole thing needs to go down. So when you move it down, yeah, I heard you say it. What has to go on top as a placeholder? 1. Perfect. Now, this is not one of our options. So when we go to like rewrite things, right, and you can kind of tell that you start this thing with a fractional exponent, but everything else has a radical. So it's kind of your clue that we probably have to rewrite stuff. What's going to go to the outside? The 5. But the bottom goes to the outside. I like the BO thing. Whoever said it over there. The little trick. Bottom goes to the outside. All right. Top. The numerator goes underneath. Okay, so it has to be choice 4. How did you guys do that one? Good. Alright, it's gonna one of the ways. It probably won't show up both ways, but usually it's one of the two. I know somebody wants to do more stuff with exponents. Try out this one. See what you guys think. Good. Thank you. Oh, this is true that. That's very professional. I thought it was like printed. I'm like, how much are you take with that? Good triangle color. Alright, so hopefully we cannot have negative exponents, so you guys are switching the spots. Right, so if it's negative in the top, it's got to go to the bottom. From the bottom, it should be going to the top. Alright, so on the top, we should have an x to the positive 5. Well, actually, ask you guys, is that x to the negative 5, is the negative 5 connected with the 3?
No.
The x?
No.
Just the x, right? So the 3 is going to stay down there, so no parentheses around it. So x to the positive 5, bless you. You should have a y to the 4th and a y to the positive 1. Underneath, you should have a 3 and then an x. Now remember, for something to be totally simplified, we can't have 2 of the same letter. So when we go to do our reducing, we have 1 on the top and 1 on the bottom.
That's 4.
Good. Where's it going to be left? Nice. Because there's more up there. Perfect. Now here, you have these on the same level. So we're going to add them, right? When you multiply, we add exponents. Good job. So it is choice 1. Good job, exponent moving. Maybe you'll get one of those too. Okay. Something like this is going to show up. A lot of you guys get the first step, but we kind of struggle with the second part of it. Right, these are on like every exam. Okay, right, how many triangles exist? How many triangles can be made? How many obtuse or acute triangles are there? Right, first thing we should do is draw yourself a picture. Okay, so A, C, we'll make it an ABC. So make sure little a is across from wherever angle A is, and little b is going to be across from angle B. Okay, now, what law do we need to use here? Sine. Always law of sine when we're looking at how many triangles exist or can be made. So we have two sides, two angles. When you guys set your law of sines up, make sure you have the side over the sine of the angle equals the other side over the sine of the angle. Yeah, cross multiply. Good. Make sure all your calculators are in degree mode. Do all this stuff. Go here, whole number. These usually don't make a big deal about it. Yeah. Okay, so you guys get 0.75 as your, right, so now remember, this is what sine x equals. So you're looking for the degree. What key do you use?
Second sine.
Yes, Mariah, fantastic. Make sure my nose okay. Yep, I know that. Right, second sine, we'll put that answer in. Okay, so nearest degree, what do we got here? 49. So when you are testing this, if you guys get an answer for the first part, so I have that angle B could be 49 degrees. So can it be 0? No, because if it was 0, we would have gotten error right in the beginning. What other one is it never? 3. Okay, good. So one way they could ask you guys is like this with numbers, or they might say things about acute or obtuse angles or triangles. So is 49 acute or obtuse? Acute. Good. So this would be like one acute triangle exists. Now to test it, we always look at our quadrants. We already did the first quadrant with our 49, but we need to also figure out 180 minus 49. We want to get into the A and the S quadrant. So if we take 180 and we subtract 49, what is it? 131. 131? Okay. Now we have to check and see if I put 131 in for angle B, does that one work too? Let's see. Well, 131, if I just look at these, am I over 180? No, so that works as well. And 131 is obtuse because it's bigger than 90. So we have 2 of them that work. Now, if you guys got your second angle here to be like 160, could 160 work? No, because then you would have been bigger than 180. They could have, there's some that say like acute and obtuse. Sometimes they say just acute only. So it would be like, so Abby, if like you had 160 in here, it would be just like one acute triangle, because only the acute angle would have worked in there. Right? Okay, why don't you guys read carefully this next one, right, the force problem. I don't think they'll give that to you as your 6-point question, but it might be like a 4-point question. Make sure you guys read very careful. Okay, so hopefully once you guys see the words like things about forces, magnitude, resultant, this is where you're making your little like parallelogram looking thing. Okay. They're not asking you about area here, so we should be drawing a parallelogram with the resultant. Yeah. All right. So when you guys look at, do you get the forces at all? Do you know these? No. Okay. All they tell us is that The resultant is 27. And that the, let's see, the angles between those are 60 and 45. So no, this one's 60, this one's 45. If you reverse it, not a big deal.
Oh, that's probably why I got it wrong.
Okay. Be really careful with the reading. They put little degree signs, and that may help you too. Now, what they want you guys to do is find each force. So we're going to make ourselves a parallelogram. Couple big steps with this. Okay. What do, and here's kind of your starting spot. What does this whole angle and the whole top angle have to add up to be? 180. Good. So if we take 180 and I subtract 60 and I subtract 45, what's left? 75? So 75 has to be that whole top angle. Okay? The entire bottom, entire top, it has to be 180.
Would you do like would you put it all in once, or would you do like?
Oh, I would do the top and then enter then divide. Because sometimes it messes it up. All right, the other thing that comes up here is a little bit back from geometry, is the idea of alternate interior angles. Do you guys remember the ones that were like the Z?
Yeah.
Okay, so this little piece is 45. Good job. The top little piece is 45, and this one's also 60. Okay, and the bottom one, 75. Okay, now the idea behind this, you're trying to find the two forces. So we need to put one x here. We'll figure out that one, and maybe we can find the other one. If it helps you guys to take apart the triangle now, that works, right? This is 27. What is the top little baby piece? 60. Nice, Aaron. Right, the top little baby piece from over here is 45. And we know this is 75. Okay, what law do you guys think we're going to be using here? Sines. Nice job. Yeah, we can't use cosines here because we only know two sides, not three. Okay, so match up your pairs. And let's figure out what one of the forces is going to be.
I really hope this is like a part 4.
Yeah, right? This would be great.
It's just easy if you know how to do it.
Yeah. Well, and my hope is that we're literally covering every kind of question over the last 3 days, so it's got to be fresh. Yeah, what am I doing? Sorry, I can do that. 27.
Kind of a little more confident now.
I'm sorry, Aaron.
I'm a little more confident now. I'm gonna go in there with like a lot of confidence, but
I hope so.
I don't know what the outcome could either be.
I hope it'll just be fair. That's like my hope. It's a fair test. All right.
I'll probably get a 64.
Let's see. Where do they want you guys to round? Pound. Did you get 20? First one? Good. All right. Make sure you guys are reading careful here. So 1 force equals 20 pounds. Now you have to make sure you answer the question. They want the magnitude of each force. So what do you guys think we need to do again? Yeah, write it again. So we know now this one's going to be 20. All right. How can I find that? Anybody have an idea for that one? What could you use now?
X sine 60.
You could use law of sines, or what else could you use? Cosines if you wanted to.
Well, sine is so much easier.
Yeah, law of sines is easier, so if you have the option, I would do that. We have to be using the x with the 60. And then this might happen to you guys. What I would do if you needed to like pick which one to use, technically we could use the 20 over the 45 or the 75 or the 27. I would always use what they gave you. You know what I mean? Like they gave you the 75 degree, well, you found that, but the 27 degrees was already something that they gave you. So I would use that part, not something that you guys particularly had to like calculate. But again, it doesn't matter. It'll be sine 75. Now, when you guys cross multiply here, 27. 27. Divided by get 24? Yeah, 24. So the other 4 equals 24 pounds. Okay, but I think that could definitely be a really good part 3 question. Yeah, okay, nice. Okay, so this is one that I see a lot of us struggle with, but we got to make sure if this comes up as your part 3, or maybe even a part 4, we're able to get answers and start it. So take a second, see if you guys can figure out, like, where should we go? Double angle, good. So right away, reference sheet, love it. Good work. Oh, I have a reference sheet too if you need one. Yeah, see, there you go. Both up here, sorry, I don't physically have them. Alright, so here's your double angle. I think that's everybody's plan.
I'm not even looking at it, I'm just studying them all. It's 3 all night, that's terrible.
Okay, so which one are we going to pick, though, of our cosine double angles? Second one, good job, because when you guys look at it, you only know things about cosine in the problem, so you want to choose the one that has only cosine in it. Alright, so we're going to take out this cos double angle. Careful with the 3, it's still out there. Now when you guys make your substitution, when I take out that cos 2x, I'm going to put in 2 cos squared x minus 1. So 2 cos squared x minus 1. Okay, everything else in the problem is going to stay the same. So I still have my plus cos x plus 2 equals 0. Before you do that though, what do you need to do with these parentheses? Yeah, distribute that 3 through.
No.
Yeah, do you want to make them all?
No,
be like,
no,
oh, yes, you're right, you're right. So it only separates by terms with adding subtracting.
Could you like turn it into like just x's now?
Yeah, if you want to make them all x's, once they're all the same trig function, you guys could do that. So if it's easier for you guys to think, you know, turn those cos x's into just x's, if that's easier for you, totally can do it. Alright, please watch out. I see a lot of like little algebra things that mess you guys up with these kind of problems. When you go to combine these, do we switch the signs or can you just combine them how they are? Combine, because they're on the same side of the equal sign. So rewrite everything. Make sure it's in standard form. A -3 plus 2 is going to be a -1. Good. Alright. Well, if you have the highest exponent squared, what do you need it equal to? 0. So this is looking good. So we can solve it. Quadratic formula, we could use grouping, we could try guess and check. Which one do you want to do? Grouping? You want quadratic? You go for it. Okay. So let's see, if you were going to do grouping, you want things that multiply to a -6 but can make a +1. 3 and 2, let's see, yep. If you want a +1, which one do you close? -2 and a +3. Good. If you multiply those, we get -6, but if you add or subtract them, we get a +1. That's kind of what you want. Alright, so with your grouping method, and again, if you were someone doing quadratic, that's totally fine. If someone asked me, if you guys try to do grouping, alright, and you cannot get something that works, that you couldn't find factors that multiply to the right thing or add into the right thing, then you would have to use your quadratic formula. So we're going to get rid of those, put these in a spot. Alright, once you guys have those 4 terms, split it down the middle, and we're going to take the GCF of each part. Okay. So what's the GCF at the beginning? 3x. Awesome. And then we should have an x plus 1. Right, bubbles need to be the same, so keep that in mind. What are you going to pull out, a positive, or what are you going to pull out with it, though?
No, I'm saying.
Oh, like.
No.
Oh, in here, you're right. Thank you. What do you guys think for the next one for the GCF? -1, perfect. Please make sure you always take out the sign, okay, that's there. So then this turns into a positive 2x plus 1. Okay. Alright, last up, join them together. Then 7 equals 0, right? Yeah. Alright, write that common binomial one time. Set them to 0. So 3x plus 1 equals 0. I want to add 1. Oh my gosh, these questions are so long. So add 1. Alright, so we have x equals 1/3, and then over here, it's going to be a negative 1/2. We set it here. Because you can bring it over and change things.
Yeah, I didn't realize that.
Okay, so listen, if you get one of these problems and you're like, I hate these, it's really important you just keep going. Because if you make let's say you made a mistake up here factoring. If your factoring stinks, okay, it's okay. But you have to keep solving, and the next part of this is really important. So then you could still be looking at like 3 out of 6 points. They want you to get at least answered. What do you guys have to make these x's back into? Cosines. Good, okay. I guess so, yeah. Here.
And then like you have to find it in the
Yeah. Mason too. Attaboy. Don't you judge him. He's a man. He's a man with many traits.
Okay, so if you guys are going to now set your x's into cosine, and make sure you remember to switch them back. Okay. Now, last step of this is super important. How do we figure out our degree? Second function key. Awesome. Good job. So let's do second cos of 1/3. Second cos 1/3. Did you get 71?
Hell yes, I did.
Good. Okay, so this is where everyone kind of forgets. This is, we got x equals, I should check too.
120.
Oh, good, nearest degree. So it is 71? Okay. Now, this is going to tell you guys what quadrants we need to be in. So, is cosine positive or negative? Positive. Good. So we need to be in the A and the C. 71's in the A. How do we get into the C though? Subtract it from?
360.
Yes. Super. Okay, so what'd you get? No, it's okay. This is my dad. This is my class. You want a munchkin?
What's that?
Want a munchkin? I knew you would pill, you know. You guys don't want it. We're doing trig practice at the Regents tomorrow.
Believe it or not, that's all it looks like.
Oh gosh. Okay, let me pause. Okay, so what did you guys get when you did 360 minus 71? 289? Okay, good. Okay, so let's check out. Do those fall in the interval that we're given? Way back up? Yeah, good. Be careful of this, that it includes 0 but not 360, right, with your inequality. Right. On the other side, alright, let's do the same thing. Oh, this is a nice one. Did you guys get one fun?
Yeah.
For equations for circle one, you put like one of the outside things into the equation.
Now let me go back. Okay, so say it one more time.
Oh, I know, I'm on like a question ahead, but it's
Can you wait till this one first? Sorry. Otherwise we'll get like lost.
what about this negative 1/10? Just find where the cosine.
Alright, so once you guys get your 120, is this going to be something where cosine is positive or negative?
Negative.
Negative, good, okay. So, cosine's negative in these two. 120, when you guys graph this over here, how do we move
180
to
plus 120.
Close. Minus it. Good. Good job.
Shit, I'm so confused.
Alright, wait.
Wait, we're going too fast. I thought it was plus because
Well, hang on 1 second though. If you guys did, the first thing we need to do is find your reference angle in here. Right, Dana, because that's how we're going to move the quadrants, by adding over and over. If you did, think about it this way. If you took 180 and you added 120, you'd be way over here. And
you would be in 300. Yeah.
right, and it would be too big.
Yeah.
So, let's see, with the difference between 180 and 120, we're going to get 60. Now, if you guys add your reference angle of 60, what will that give us? 240, good. Alright, so all 4 of these are going to be our possible answers. If you guys get one of these questions, it's just really important. Whatever you guys get for your cos x, you do this checking, okay? Because it goes by how many mistakes you make. So if you only make 1 mistake, it's not that bad, even if you get the wrong answer. I think that would be like a 6-pointer, yeah. Yeah, there is a lot to it. Okay, this one is very similar to a couple that we had issues with during class. Take a second and think about this one. We kind of got tricked, but hopefully we've seen it enough that it won't come up. Yeah. What's your outside point? Did you use an outside point?
Yeah, it was like,
Well,
yeah, the point is 20 times.
You have to find a point.
Especially the leader is 30. 20 is only 4.4. Yeah. 20 was signed. 5. Yeah, but it's not exactly 5.
Yeah, that's fine. So then otherwise, that's our square, right? So if you took the square root,
20 equals our square.
yeah,
Okay.
yeah, that way if you always get back in, it'll always get you the
I
right
just
way.
didn't know which I didn't.
That was tricky because it kind of like made it like it would work.
Do you have like a separate reference table?
Reference table? Yeah. Alright, let's see what you guys got so far. Okay, so you guys saw this come up with secant, but it's kind of similar.
1 over.
Good, okay, so this right away, if you guys try to find your second cosecant, we don't have that button on the calculator, right? Not there. So we have to use the reciprocal, which is 1 over sine. So instead of doing 1 over sine though, we can use our sine, but what would we have to do with this fraction? Flip it. Very nice. Now, can we do our second sine? I think so. Let's try. So second sine, -1/2. Alright, -30. Let's see, is that an option?
No.
No, okay. So if you have -30 degrees, what is that like? 330, good, because you're going down. Here's your 360, means you're going down 30, which is 330. Okay? Oh no, that's not an option either. So we have to look to see sine is negative. So here's your little ASTC. Where else is sine going to be negative? Good, the third one. Okay, perfect. Here's 180. How do we move into the third quadrant? Add, good, because then you're going, numbers are bigger. Think about, here's your numbers, Anna. If you're going from 180 to 270, you're increasing.
Yeah.
So that's going to be half the adding. What are you at? I'm at 180. What are you going to add, though? 30, good reference angle. Very nice. And that will give you your 210. You'll probably get one of these. It might show up something like this, or it's going to be one of the brutal ones you just did. I don't know. Okay, let's see. All right, circle one. These are pretty easy. We got to make sure we get them right.
It's not 1 or 2.
Move this down so you get more room.
That'd be some 14.
Oh, you're right. That was good, man. You could get rid of a couple of these right away. Bigger.
So good.
He's been at like every review. He's been doing good. Okay, so right away, yeah, I'm gonna pick on you because you knew this. Which ones could you get rid of right away here?
1 and 2.
1 and 2. What's the center of these two circles? The origin, good. It would have had to been 0, 0. That's why there's no parentheses. So it can't be 1, it can't be 2. So let's find the center first. 1, 2, 3, 4. So it's -4, 2. Okay. What do you have to do when you guys go from the center to equation? Change the signs, flip them, good. So when we look at our equations, we want a +4 and a -2.
So both of those.
And both of those, all right, so that doesn't help me too much. Now, when you look at your equations, though, so far in your circle, we know we have the +4 and then the y - 2 squared. Does anybody remember how we can figure out the r squared? Outside point, very nice, Rita. Okay, be careful when you choose your outside point. I know it's kind of small on yours. You want to find one that goes right into the corner of the squares, not something that's between them. See how that one's like between on the side? You don't want that. So find a good point that's in the corner of one of the squares. Anybody know one that we can use? There's a couple in here.
-1, 2, 3, 4, 5.
-1, 2, 3, 4. This one's it's a little over. 0, 1, 2, 3, 4. Ooh, that's a really nice one. See that 0, 4 on yours? See how it goes right into the corner? Okay, so let's put in the 0 for the x and the 4 for the y, and we'll substitute them in and see what we get. So 0 plus 4 is 4 squared is 16. Good job. 2 squared is going to be 4, which gives us 20. So that already gives you guys r squared. By doing it this way and subbing them back in, you already get what r squared equals. That like automatically gives you the formula.
Can you just look, because like what me and Anna did, we looked at like this circle, and it was like somewhat over like the 4, or where it would have been 4, so it's hanging over a little, so it's like 4.5.
Oh, yeah, you could think about it that way.
Is like 4.5.
Yeah, that would kind of been narrowed it down for you, definitely. And the only thing is, it's one like a part 2. You could get that, you got to show it. So, all right, that was good. You guys are doing a good job with your circle stuff. All right, let's see what we got next. Oh, all right, good. We did completing the square yesterday, but we haven't done it with the circle stuff. So, see if you guys remember what's going on with this one.
Oh my god, Randy. I looked at the one down below and nothing. And I looked at the one above it and I'm like,
I just kind of like stopped at the.
I don't do the eyes up in there.
Well, no, because it's just
Yeah, we gotta
not
do it.
Oh, yeah, then that's okay. I gotta find that. But if you see, I'm gonna do multiple in case.
Yeah,
you guys remember.
2 hours.
and then you can do the square root.
But there's been like 2 hours, 2 hours.
Square the number.
Yeah, you square it,
That
then
adds
square
up.
the 3.
Now you split it.
Yep.
Yeah, we're not even on that.
Okay.
Because it's like that. Isn't that what you do it for? Yeah.
You want to do the square though, not because they're X and Y, so it's mixed.
I was gonna take you for breakfast, but what time are you done?
I'm not settling at all today. I have calc after this. Sorry. Okay, next week.
Good luck at the exam tomorrow.
Thanks,
Yeah,
Dad. Bye, Dad. Love you. See you later. We'll talk about football all day long.
I know.
He's the man. Why are you straining down?
All right. Okay, so with this one, what are you guys going to do first? Good. Group the x's together and group the y's together. Okay, so put all the x stuff together and then put all the y stuff together. Good, nice job, Aaron. All right, all your constants have to go over, so anything that's just a plain number, move to the other side. Great, okay. So with this, when you're trying to make this into the equation of a circle, we have to use completing the square. So you want to take each of these kind of separate. Okay, so we're going to make our bubble, put the x in, put our little square in, and then we want to take half a -16. -8. Good job. Okay, perfect. So, what you guys put into your bubble, what do you have to do to the other side?
During the time when we stopped telling the story.
Oh, okay. Alright, so we're going to add over 64. Okay, -8 squared. Now with the other part, we're going to do the same thing. So put your y in, square it. What's half of 6? 3. Good job. Okay. So now we're going to square the 3 and add it over. Yep, you just take half of that term. So now we're going to add 9 over here. So at the end, if you want to figure out what the r squared is, we're going to add all those together. So let's see, 64 minus 53 is going to give us 11. It's going to be 20. Yep, awesome. All right, so this is what it is. Now I'm going to answer my question. I just did a little bit more than we needed to. So it asks you what these center coordinates are going to be. So if you have a -8 and a +3, when you put it back in, good, make sure you switch them. Right, so 8 and then 8 and -3. Yep. That was good that we went over that one. That is, like, show us off once in a while. Just a little tricky how to start them.
The one that I thought I got was
Okay. What do you guys think for this one? How many different 11 letter arrangements? I think you'll get one of these. It's going to be an easy one. You got to make sure you enter it right in the calculator.
Oh, you need to do iPod. I got that.
This is the one.
The exclamation points, not the eyes.
Yep, you should be able to use the calculator for it.
Okay, well,
I did, I got that.
Okay, you're making the common mistake.
You look at the.
You gotta do the top first.
Where I hate myself.
You don't have to do that, right?
Little do you know, I actually hate myself more every day. Little do you know.
All right, so arrangement. What goes on the top? 11 with what? Factorial. Okay. So on the bottom, this is where people make a mistake. Okay. So you need to figure out what things repeat and how many times. So how many A's do you guys see?
2.
2. Okay. So I have 2 A's, 2 R's,
2 N's.
2 N's. So
There we go. Now we're
2 E's. Okay. Is that everything? Okay. Here's, if you guys got something I said was wrong, what do you need on the bottom, Sophia? A big, gigantic set of parentheses. If you do not put this in on your calculator, it messes up the order of operations.
I hate myself.
Okay. So when you type it in, all right, do your 11 factorial first. But math, TRV, oops, not choice 1. Okay. Guys, and that, make sure you put that one big set of parentheses. I know it's a pain to kind of put in the calculator, but.
Yeah.
Okay, there we go. So we should get.
Yes.
Right, and that's very different if you did not put the parentheses.
No, if you didn't, you got 18,000. 18 million.
Oh, that was just like a certain case. They wanted you to see, like, technically, I can, once you found this, I can give you a bunch of different random, like, things and say which one. They just wanted you to actually show up each multiple choice.
I don't think he showed up once.
Yeah, that was
He did.
He showed up the one.
Because I made him come. Because I made him work.
All right. Okay. This is another one. I think you guys will get this as your part, as a part 3. Okay. It shows up on every exam. We got to get it right. I know we struggle with finding which one is which. So take a second, read it. See if you guys can identify.
What part of this is part 2? Part 3. Oh, these are so easy.
Yeah, and you got to make sure they're like, that's going to be a huge, huge thing if you're going to pass or fail. Like, some of these part 3 and 4 questions. 5 plus 1/2. All right. Anybody want to share the formula we need to use?
NCR, PDR,
Oh, good job. NCR, C to the R, q to the n minus r. Good. All right. Please make sure you guys are organized with this. Identify your NRP and Q. Anybody know what the N is? 5. Good. So you're talking about a total of 5 days. N is always the total. R is what you're looking for. Good. Nice shot, Andrew. All right. Make sure at least, guys, you're going up 3, 4, and 5. What about the P? What's the probability that our bus is going to be late? 1/3. What about the Q? 2/3. Super. Okay. Make sure, guys, at least, at most, no more than you're doing more than one thing. Right? You have to go up or down. Exactly. It's just one. Alright.
You get it or not?
Yeah, a little bit.
So 5 means 3.
I feel like they always use 5.
You know why? Because they don't want you, if they use like 8 or something and they said at least 2, then you'd have to go like 2, 3, 4, 5, 6, 7, 8. So they try to do like maybe 3 math. Bless you. Bless you.
And these are like the easiest problems.
Yeah, I hope you guys get one of these at like part 3.
All this is typed it in the calculator.
Yeah. Make sure you guys type them in right though, like after you're done.
And like,
Wait, so am I supposed to get in the decimal? Before I start writing the decimal now?
I know.
Yeah, don't need it all of it. Oh, I see.
I just set it up like this. That's why you find something else when you have to just that way when you create, like, you just put the answers here.
Here, I have a question. Did I put this in?
Yeah, 1 second. Yeah, this is fine.
You get a point.
Get this in 4.
And you add them all up at the end, right?
Yep, yeah, I'm all there.
You probably, right?
What you got?
Wow.
This looks weird. 120. You usually don't enter the whole number.
Yeah, I kind of thought.
Do you do this all separately or together?
Probably wrong.
I did this last time, that's how I got it together.
Alright, so one more thing real quick. Explain to me the stupid second number.
Oh, 120 down, but.
I'll tell you one second.
Oh,
Okay, so.
you like times that.
So you just
I would do it all at
Oh,
once.
I divided it, that's what I did.
literally take 1/3
Is it taking
minus 1. 6, sorry.
It
Fraction.
doesn't say anything. I would do like the whole thing, yeah. Okay, when you guys add this up,
Let me be 3/4.
0.209.
It needs to add up to 1. It needs to
No,
add
no,
up to 1.
alright, ready? This is gonna be easy, right? What's 1 plus 3? 4. What's 4 over 4? 4 over 4 is 1. That's what you final product. So 1 over 4.
You're looking for it to be so
No,
whatever
let's do like a
adds to this
fraction.
1.
Okay, so whatever fraction you get, 4 over 4
Mine's
is
probably like
Basically, and then you
okay, so it's like 1 over 4. Here, do 1 divided by 5.
Yeah. Can you go back to that?
Minus 1. Yep. And then so
4 over 5.
You're gonna have to get 2 of
Just
them.
think, 1 plus 4 is 5. Divided by 1.
Yeah.
Just whatever you do. That's all. That's how I do it. It's just literally what you would get to get 5.
No, yeah, Dennis right.
I wish I would.
Because checkout field says that surplus is least 1/3 of the time. What they actually find is probability, yeah. Yeah, so see how these are the same thing, just keep it between.
No.
Oh no, you
The
got
only
two
way
easy
to ask
numbers.
is
You know you do that. You do that.
then you do.
I do that. So you have 2I radical 32 and then split it in half. And then 16.
Oh, so you literally just put an I after it.
Okay, first try is done. All right. You can put any of these, and they're easy, but if you don't see them, some would be a trick.
Yeah, you need to do it. I have no idea how to do it.
Good. All right. So when you have a negative under a radical, really, really bad, right? You have to cross it out and put a I in the front. Okay.
2I.
So 2I radical 32 minus 2I radical 8. Okay, now we're breaking down radicals like normal. So just what you guys would normally do. So how do you guys break down a 32?
2 and 16.
16, 2, good. Okay, 16 becomes a 4.
2 goes the other.
Good. What operation goes out there? Multiplying, good job.
So 8I.
8I, yep, radical 2. Okay. What's 8 going to break into? 4 and 2, good job. Alright, so those multiply, we get it?
10I radical 2.
9. Okay. So 8I minus 10I?
Is -2 over.
Good. Radical 2.
That's it?
That's it.
Oh, my.
Right? Super easy. But just make sure negatives under the radical are really bad. So right in the beginning, get rid of them, make it an I, just simplify. Okay. Alright, we did this a couple, maybe not yesterday, but I think it was the day before.
No,
And
yeah,
I
it was
told
the
you
day
guys, I think this could be a 6-pointer for you. Something like that. Okay. So solve the solution, solve the following systems of equations. So, good, we gotta get the y by itself if we can. So, we wanna see, you're looking to see where these two things cross. So the first thing we wanna do is get y by itself.
So 5 plus X.
Good, 5 plus x. Okay, so y plus 9. How would you guys get the y alone over here?
Y equals
Add 17x. Good, minus 4.
squared.
Perfect. Now, what about if the y was squared? Could we do this? No, that was when we had to do substitution. So this one's nice. We have both of them are equal to y, so what do we do with them?
Set them equal to each other.
Awesome, good. Okay, so 4x squared plus 17x minus 4 equals 5 plus x.
This could be like part 2 if the y's were equal to each other.
No, this could be like a 6-pointer. This, I think, actually was a 6-pointer.
Like this.
So this
easy?
Yep.
Wow.
Alright, so minus the 5, minus the x. Okay, how do you guys want to solve this thing? Grouping. Okay, good. Why don't you try grouping? See if that'll work. If you did want to do grouping, you could always use quadratic formula, right? That'll work.
Nothing is gonna.
Yeah, 36 divided by 2.
Oh, you can do it this
So
way.
that's not gonna
I
get
never
that.
thought of that. You can do it
So
that
you
way.
have to make the 16 then?
And then
Yeah,
you
you have
just
to
like
make the
so.
16.
Let me just make sure that'll.
Like the passive.
You get to 36.
Okay. Actually, I'm just gonna do it because usually, like maybe both of this time, maybe would be
Minus 2.
negative x squared plus 9.
No, positive plus.
And then that can't be this. So multiply this one by negative 1.
I don't get to do that.
And then this will change to
4x
2x
squared.
minus 3.
Isn't it? Wait, isn't it?
And then this would be x minus 3.
Positive?
This was the hardest one I could find.
It's positive, they have to make it positive 16.
Probably was
There's
figure out,
18.
so I didn't feel
Right,
like
you have to make it
Right.
positive.
You have to make positive 16.
Do you think our reason
That's
was
what
hard?
I mean.
Subtract 2.
I hope not. I think you'll get like a couple more questions. I hope that it's not going to be terrible.
So it's 4x squared 1.
4x squared plus 16x minus
What did you guys get for your factors of 36 and
16 and 2.
18 and 2? Good. Which one's the plus? All right. When you organize everything, let's see. Which one did you group with the 4x squared? The 2?
16. Oh my god, why am I putting 16?
I know. Maybe put in there. I'm gonna put the 18 next to the 9 because it'll be easier for me to factor. Doesn't matter. All right. So when we split it down the middle, 2x should be our GCF, then 2x minus 1. Right. What did you guys pull out of the other one? 9. Yep. Good. And then.
Wait, what's that?
What's right? Go ahead.
What?
Oh, you're talking now? Okay. Now, group your two GCFs together. We should have a 2x plus 9, and then 2x minus 1. Okay? Alright, the last step, set everything to 0 here. So we should have x equals negative 9 halves, and then x equals 1 half. Perfect. Alright, now, are you done?
No.
No, okay. Watch out for these, because they'll try to, like, you feel like you're finished, but you're not.
Negative.
Well, we get a negative.
You have to take the y out.
Yes, Katie. Right. Remember, solution to the system are the ordered pairs where these two things cross. So, we have our negative 9 halves, and then we have our 1 half for the x. To get the y's, we have to pick the easier one and plug it back in. So, I think that this one's probably the easier one, right? 5 plus x, way easier. So if I take 5 plus negative 9 halves, let's see what we get there. 5 plus, you get 1 half.
This one or 130.
Okay, so this is going to be 1 half with it. Now if I take 5 plus 1 half, let's see what we get there.
11 over 2.
Okay, 11 over 2. Okay, so then 11 over 2. So these are your two answers.
Wow.
Right. This is something you may get, I don't know, but if we don't practice it, you might not remember. You might feel like it's just a word again, so word. Yeah.
Weave them up around and dry them.
I'll have a mold. He's like, I'm going to 30 minutes to a psychiatrist. And then on Wednesday, 30 minutes to a psychiatrist. He's talking about falling off the couch. You got mad.
Did you just do it? You did it.
Needless to say.
What do I do?
I was going to try to plan the other day. Just thinking about leaving after the road. I was thinking about leaving they're gonna be fine. Yeah, they'll be fine.
I was thinking about,
Did you ever follow it?
I was just thinking about
Oh, okay, then I just called you. Oh, right,
Okay.
oh no, that definitely.
All right, so this one is pretty difficult because we haven't done it in a while unless you came to review and spade the first day. Does anybody know what type of sequence this is talking about? Recursive. Good. Okay. All right, this is a recursive sequence.
The recursive.
Okay.
Reoccurring.
Sophia, what's your clue that it's recursive? How did you know? It was just being here.
Oh, I didn't.
Oh, you didn't have it. Oh,
The 7.
Frida,
Huh.
what made this know that it was like
Well,
recursive?
because they give you a to the 1.
Good, it gave you this, and what do you see over here?
A n minus 1.
Good, this little part where you got the n minus 1, that's your clue that it is recursive. Usually they'll tell you, find in this recursive sequence a certain term. They may not though. So with recursive sequence, it deals with using the previous term. So we started with a1 equals 3. We want to find a sub 2. That's your next goal. Well, here's our formula that we're using. an equals n minus 1 plus 6. So as you guys are finding your terms, if we want the second term, what do you think you're going to plug in for for n?
2.
2, good. All right, so it's going to look like this. A to the, instead of n, we're going to do a 2 minus 1 plus 6. Now, we want to reduce this. What is 2 minus 1? A1. So what is A1? 3, good job. So we're going to take the 3, the previous answer, and plug it in this spot. So 3 plus 6 is going to give us 9. Awesome. Once you guys kind of figure out the pattern, you don't have to keep like subbing in, but you might need to kind of figure out what's going on. So now if we want the third term, where you guys see an n, what do you want to put in? 3, good. So it becomes a to the 3 minus 1 plus 6. Good. So what was a sub 2? 9, good. I'm going to take the 9, plug it in. Good job, 9 plus 6, 15. All right, so again, once you guys get the pattern, we can just kind of keep going now. A sub 4 is going to be 15 plus 6, which is 21. If we want the fifth term, we're going to do the same thing. 21 plus 6, which is 27, nice. And then the sixth term, let's see, 27 plus 6 is going to give us 33. And a sub 7, 33 plus 6 is 39. Right. But see how once you get the pattern, you guys can just like figure out what was subbing?
The pattern?
Okay, I'll take that as a yes.
Yeah.
Thanks. Okay. Oh, all right. Some of these I just thought were good to go over. A little bit tricky stuff. What? Do you have time with this? Oh, we got the English region. All right, good luck. Good luck, good luck. All right, so with this next one, you guys are subtracting fractions. What do we need to have? Good job. All right, so if you need to factor things first, and then it might help you decide what's the same. Right, what are we going to make this into? 9 and 1. Good luck. 9 and 1. Great job. Perfect. All right. So whenever your name comes down here, what one fraction has, the other one leaves. So what's this one missing? X plus 1. There's a couple pieces of the trick.
Can you cross out before you
What do you cross out?
like at the bottom of the
Oh, I see what you're doing. Okay, wait a second. These two questions are very different.
Oh, there's no equal. No.
Yes. Okay, you cannot cross the bottom out here because there's no equal sign.
No, cross out x plus 1 and the top x plus 1.
If you factor the top thing,
Like, on the side of the
Oh, with this one, you mean?
the top part.
like if you factored it out, it would be like 2 parentheses and then one of them would be x plus 1. So could you cross the x plus 1 on the bottom and the top out?
Yeah.
Yeah, that should be okay.
Okay.
That should be okay.
What about the x plus 1 and the x plus 1 on the
This
left?
side?
Yeah, the top and the bottom.
Okay, you could, technically you could do it because they wouldn't need the common denominator. I'm going to keep going with this way. just because it might not always work where you can factor the top and do something like that.
Yeah.
This is kind of like a weird thing that you can do it. So see if we get the same answer. If you did it that way, it should be okay. Now, once you guys have your common denominator, right, you can't cross these out because there's no equal sign. This one there is. So in the top, I'm going to have my x squared minus x minus 2. Please be careful of this. What are you distributing through? Negative. Okay, so minus x minus 1, and then the whole bottom is x plus 9, x plus 1. Okay, so when we combine some like terms over here, we have our x squared, and then what's next? Good, minus 2x. Good. And then 9, x plus 1.
So, it's like a.
No, it can only go to one spot, just that.
Okay.
Can we factor this? Okay, so x and x. We should have a 3 and a 1, and it has to be a positive 1 and a minus 3.
That would be x minus 1 over x.
Okay, so the x plus 1's go, so x minus 3 over x plus 9 should be your final answer here.
Yeah, that wouldn't work on the other one because it would be x is 2 over x plus 9. Yeah.
Oh, so it didn't work the other way?
No, but that, how.
Did you make some other mistakes in the other part?
Actually, the x2 plus, oh, actually, yeah, it would be x plus 3 because 2 plus 1.
What would you get if you got the right answer for a question but used the equation the wrong one for the question?
What did it say wrong?
What would you get if you got the right answer for the question but you used the wrong equation? You still got the right answer.
Is it a correct method though? Or is it like totally wrong method and just randomly you got the answer right?
Both, I don't know.
So that's like the best. If like it's an okay method to use, you would get full credit. But if something that's like so out there, you just like guess the right answer, then you get 1 point.
Okay.
All right, this one is I think the hardest way you guys would see it is kind of a problem, right? With a fractional equation. Very similar ideas of trying to get the bottoms all the same, but we have a trick part here. Okay. If we factor the x squared minus 9, we get x plus 3x minus 3.
Do that for the other ones.
Yeah, good. All right.
Could you do it?
Okay. This part in here, guys, watch out when you go to make common denominators. If you have 3 minus x and x minus 3, are those the same thing? No. Anybody remember how you could turn this into an x minus 3? Good. Multiply by -1. Good job. That should be my first step in here. If you need to take this into 2 steps, feel free. So if I need to do this in 2 separate sections, it's totally not a big deal. You just take as much time as you need. Now, if you take a -2 times a -1, what's that turn into? Positive 2? Okay. Negative, negative. Now, if you take your -1 and you bring it through, what does 3 minus x become? Yes, you have x minus 3. Good. Okay, equals 4. Then we have our x minus 3, x plus 3. This makes it a lot easier to work with. Now we at least see that certain things are the same. So what one fraction has, the other one needs. This one's going to need x minus 3. What's the middle one need? X plus 3. Okay, so we just have a lot of distributing, solving. Now this one, since you have an equal sign, what could you do at the bottom? Yeah, get rid of this. We're solving an equation like normal now. So we're going to take our 1, bring it through. So this is a little bit different than we're used to solving these crazy, crazy equations. Do you guys have anything with an x squared? No. No, all right. So I'll combine some like terms. 1x plus 2x is 3x.
3x minus 3x plus.
Plus 3, good, equals 4. Now, since you don't have an x squared, how do you solve this?
Minus 1. Back to 1.
Minus 3, get all the x's to one side, all the numbers to the other side. So minus 3.
So 1 over 4.
Good, yep. Divided by 3. So x is going to equal 1 1/3. Now, with these problems, they're going to be tricky. What do you have to check for? 0 on the bottom, nice Katie. We want to make sure whatever value of x we get will not make a 0 in the bottom. So if I took 1/3 plus 3, will I get 0? No. 3 minus 1/3? Is that okay? Negatives are fine. We just here we can't get a 0 on the bottom. That's all right. And 1/3 squared minus 9, that's okay too. Okay, so that is definitely the answer. All right, and this one, you're gonna get this somewhere. Okay, it could range from a part. I think you guys probably saw the one that's a part 6 like this, right? But how to start them? These come up all over the place. Right, you're gonna get one of them tomorrow for sure. Andrew, what do you have to do first? You look at the
We have to break down 32 to
Good job.
and 4 to 2.
That's good. That's okay. No, you're all right, good. Okay, this is one. You guys have to get the basis to be the same because you have the x in the exponent. So use 2. So 2 squared is 4. Okay. Keep your exponent there. And then 2 to the what was 32? 6. Awesome. Now once you guys have the bases the same, got it. Good job. 5x equals, be careful, you remember to distribute.
4x.
Yep, you got it. Right, minus that 4x. You should get x equals 2. How was that one for you guys? Good.
I thought you said like 2 divided by 5. And I was like, what?
Oh yeah.
No, it's okay.
That was great. You guys did so good. So this is like the stuff that I had made. What else do you guys think you want more practice with? I'll look up whatever questions you guys kind of want. Biggest case, more or less. Okay. I want one with like different wording for you guys. Let's see. Okay, here you go. Why don't you guys, we've done this now a couple times. I think you guys can just start this on your own. Let's start it and we'll see how you do. Do you guys use graph before? Right, exactly.
Right.
She said, whenever we need them.
Feeling better about that.
Good.
Should I do like a way are you going?
You think that like you have to teach like during economics, you should just like just like have like their views and stuff like that.
Oh no.
So if you just like
Why would they teach that?
it would take that.
Well, whatever it dies.
Oh, whatever it dies.
Back in the day. You can calculate.
Yeah.
3 to 5.
Whoa.
My train.
The only problem I have is just when I get down to it's fine.
Because I help.
Okay, so once you get, you know how to.
Yeah, I know how to divide.
All right, awesome, guys. So, let's see, hopefully you'll have enough time to start this. BC is 10, AB is 12. Let's see. When you guys set up your law signs here, 10 times 50. Okay. What did you get your first angle to be? 67. Good, okay. So now we want to test out. If I put 67 in here, am I okay? Yeah. All right, you're not over 180. So 67 works. You always have to test. You already did the first quadrant. We have to do the second because of the sign. So if I take 180 and I minus 67, what's that going to give us? 113, yeah. So now if you put 113 in here, oops, 113. 150 and 113, am I over 180?
No.
Nope. Okay, so how many triangles work?
2.
2.
Okay, good.
Since we use signs and
Yep, that is always. And with these ambiguous keys, you're always using signs.
So
So it's always the first and always the second.
Alright, so once you all find that person, you'll just subtract from one.
Yep, all the time.
And
It's
if
never
doesn't
going to
work,
change.
then it's just 1.
Yep.
Okay, alright.
Yep. Good question, Jules. So that you're going to totally see an ambiguous case. We always put one on. What else?
can we do that one where it's like NCR?
Like this kind?
NCR everywhere.
Okay. While you guys are using your calculators, let me make up another one of these. Okay, if I give you how would you guys solve this thing? And then add up stuff up. We're gonna like clean it up a little bit, but pretty that's like a great idea. Okay. So this is kind of similar to one of the ones we did. What do you guys have to do here first? Switch it. Good. So this is gonna become what?
Tan x equals negative 1/3.
Negative 1/3. Good. So remember, we don't have second cotan, so we got to use the reciprocals. By using the reciprocal of cotan, making it tan, we flip our fraction. Now we can use our second function key. So second tan negative 1/3. And you get negative 18. Now, usually I should have put a little interval up here. Usually you guys have 0 to 360. Okay, but negative 18, well, You want to be in the tangent or tangent negative. So let's see. A, S, T, T. Tangent's negative in 2 spots. Which quadrant? 2 and 4. Yes, you want to be in this one and this one. Negative 18, if you take 316, we go down 18.
Why isn't it negative in there?
Why is it negative in there? Because usually they give you only 0 to 360, and if you have a negative angle, it's not in the interval. So what you asking?
No, in A, like why isn't it?
Oh, because all of them are positive. A stands for all,
Oh.
so everything's positive in quadrant 1. This stands for where they're positive, so it's not positive, it's negative there. Okay. So if you guys took 360 and you subtract 18, what are we going to get? 342. Thanks, Raj. Good. 342. Now, in the other quadrant, here's your 180, right? We would have to go back 18. So if you subtract 18 from 180, what would you get here? 162. Good. How is that one for you guys? Good. Kind of catching on now with those reciprocal ones? Good. Okay. All right, everyone do a oh, all right. Let me do this because I'm right on the page, but. Oh, I don't want to do that one. All right, which, let me see. All right, look at number 3 here. Well, I'll do another one for you, but this is a good one too. How could we tell which type of graph this is? Graph it in your calculator. Okay, which mode do we need to be in if we're doing something with a trig graph? Radians. Okay, see if you can figure out which is this going to be, like arc sine, arc cosine, secant, cosecant.
Why did they put it in your calculator negative? Why did they do arc
Yeah, do your calculator. Make sure you're in radian mode.
Why arc sine is the negative?
Yes, arc sine, guys, is like sine negative 1. It means second. Same thing. Arc cos is cos negative 1. These, so we have to put this in as 1 over cos. This one has to be as 1 over sine.
Yeah, because you remember you have to like. I'm gonna make a calculator. Why are they Right, but is it possible that it's not? It's just looking at possibilities. So unless it's like, well, right, yeah, you have to consider that you technically could have other. It's like it's very like open solution. So that's it's kind of the it's a strange that you get started. But we're also wanted to average. Oh, wait, sorry, this is one. So now, we stack it, I'll show you the slide, but to see where things like when you graph them, you have to use your eyes.
Already gonna love it. Yeah. Well, no, I like the idea until like, because I actually did it from two tests.
Take a shot every time you're gonna be able to write.
I'm doing that. So you know, yeah, no.
And you want to measure out there.
Oh, actually, wait. I'll make mine no, but I'm for real.
Show people one. Probably not. Have it actually like stack it up so you know it's like half. Usually those are numbered.
Oh, yeah.
Okay, what'd you guys get? 1, 2, 3, or 4? Should be choice 1. Okay, if you're not sure. Alright, make sure your mode is in radians.
Oh, can we do one of those questions, the, trig graph questions?
Yep, oh yeah, well, yeah, we've done that.
So the one where you have to find out the, like, construct your.
So if you guys kept this thing going, alright, here's what it looks like, over and over and over. You want to see where does it cross the coordinate plane. That's the kind of key with these. Yours should have been our sign. Alright, let me get you guys one with a trig graph. Oh, sorry.
I'm looking it up right now.
Yeah.
There was a meeting for sports, so when we come right home, we're really every time we're
When does 4, 5 end?
1103. 4, 5 ends at 1103.
Well, when you like, what is it?
1041.
I like the.
Oh, exactly right now. So you guys want to like make one, right? An equation.
Will you be putting this up on the website tonight?
Yep.
Oh, it made it work.
Okay, here we go. I think this is what you guys are talking about? Yeah. Okay.
Trig equations are also really good.
Are you 5? I am.
What happened is
I was like, I'm going to try to get it started.
I always like, wait, I really.
So you guys are in that like,
3 meters or more.
if you need to, we can set up one in front, so.
Okay, obviously that's the whole time. No, why not? Honestly. Awesome.
I probably should have thought about it.
Really like. I'm in there with you guys. I'm in there with you.
By one or whatever.
All right. So when you guys are drafting this thing, when you write an equation, we've done this like over and over. What do we need? Y equals. Good. Okay. The first thing we need to find, when you guys do a trig graph, it's usually in the form y equals a, then like your trig function, a b, and then your f.
Is there sometimes we have like where it moved out?
It might like a plus c or plus e at the end, but see how it's the same distance?
Yeah.
So it's not. There's no up and down shift here. Okay. So let's look for c here. The first thing you find, the a is the amplitude. So if you split it, okay, what's it going to be? Good job, Sophia. Nice. It's 3, but because the sine graph, because the graph goes down first, it has to be negative. Now, the trig function is this sine or cosine? Does anybody know why? Starts with 0. Good job. Okay, this part's very tricky. The b is the frequency, and this is how many full curves you see between 0 and 2 pi. All right, good job. Watch your scale. They always try to mess you guys up with this. So if you imagine 2 pi, double 2f. Got it? Nice, nice, nice. Good job. No? Okay, go ahead, Rando.
I don't know. Any of it. Okay, wait. Well, I thought it was 6, but A.
Okay, it's like, you gotta cut it in half. It's like from the middle part up the middle part down. Like 3 and 3. Yeah, 3. You wanna, okay, let me do it.
You want me to do like half of the one
Right. Oh, here's the other one. All right, here, let's try one more of these. Good job, good luck tomorrow. You got this. You got this one? You guys will only get one of these kind of questions.
Alright, if I get it wrong this time, then I can feel it.
Okay.
It's not gonna be a different color. No, I feel like it's
Can we do the trig equation steps, like where it's on both sides?
Go get me one.
Or where you can only move one side. Can we do the one side so you can't touch the other side? Okay.
Or vanilla.
Oh, if it's jelly, we can do
Whatever it's
one.
called.
Yes, good. Get rid of those. Okay, so this time, what do you guys think for amplitude? -2. Okay. -2.
Wait.
Oh, Miranda.
-2 equals 1/2 f.
Cosine, I like that.
Is it 1/2? Or is it
Just x, because look here, cosines look like the horseshoes. So between 0 and 2 pi, you see only one of them.
Okay, quick question. So cosine, the first number is where it starts. The side, the first number is.
It goes through 0.
Are they
Okay, so
are we done with these? You would think of cosine and sine and.
Yeah, well, just cosine and sine. They're not going to have you make a thing for tan, cosecant, all those like look the same. So the only ones they'll have you like do an equation with are the sine and cosine ones. And those are like the same properties, like doing the amplitude, frequency, all that stuff. Alright, I want to find identity for you guys.
Well, I mean, he's probably just gonna invite stuff. I'm not gonna do it. I thought you were gonna free that you sound like this. Exactly not. So are you gonna bring him to the party or are you just doing him until you feel like you can get him?
Let's see, Frida, I don't know.
Frida. Alright. But I can't say anything because our kid is. Yeah. But the anniversary is.
Frida, I don't have like identity ones, but this might work. Oh, junk. Sorry, it's fine. Something like this is kind of similar. I think that you'll get one of these, not. Okay, simplify this.
Okay, take your time.
What is the last thing? I think it's cos squared.
What?
I don't know.
Wait, is that a multiple?
It's a multiplication sign on top.
If it's a multiplication sign, can you cross out?
Yeah.
Okay, good.
So what do you guys want to make tangent? Perfect. Okay, so now you guys have a fraction over another fraction. So to do copy, change, flip. So if I take sine x cos x, sine cos x over sine x, cos squared x. Good, Dad? Good, okay.
What is the one where it's like you put like a
That's a freedom from out. I don't see them on. Like, I can't find a lot of questions with them. It would be almost like if you guys got this and it says equals cos squared. Like, that you would only be able to move one side, but you have to do all this that you did to get it equal to this. But the idea is the exact same thing. Like, you always want to make things in terms of sines and cosines, and then, like, simplify. So just always rewrite them, and hopefully things will, like, cancel out. What about, this is just random. If you guys see anything, 1 minus cos squared.
sine squared.
Good, Frida. That equals sine squared. What does 1 minus sine squared equal?
Cos squared.
Good. Because sine squared theta plus cos squared theta always equals. Okay, I really had some of those. Frida, is your birthday coming up?
Yeah, August 13th.
Ooh, pretty soon.
Frida, I have a birthday. I'm gonna be away from mine. This is birthday. Oh, well, then never mind. Where are you going? Kiowa Island. I don't even know. My dad Warren got married. So I've never seen. Did anyone else get this stuff? What is it? No, I think it's because you might.
Oh, I love this question. Hang on.
I don't know what you would. Yeah, they're not gonna do.
I know. Alright, we don't actually have to calculate this one out, but let's see if you guys can figure out some of the some stuff on it. Or maybe the formula we should be using, some of the other things. You don't want to actually calculate, you don't have to, but this is an easy one actually to calculate. But make sure you can identify things correctly. It's got a little bit of a tougher part in it.
I always get confused if the number is 4 or 7. Like, or if it's the probability is 1 or if it's probability.
Oh, okay. So, well, one thing I just told Abby is that you never want to use the N and the R to make the probability. They're always like separate things.
Wait, okay, so it's the N7 and the R is
I'll let you guys think about it and then I'm joking. Yes, good, you got it. Alright, so with this, a lot of times I've seen that they like you guys to like actually find a probability. So how many questions you got on this test?
7.
Great. Now the tough part is you're trying to find the probability that you get a question right, and they say each question has 4 choices, like A, B, C, or D. So how many of those are going to be correct? 1 out of what?
4.
Good. So the probability is 1 out of 4. What would the Q be?
3 out of 4.
Good. And how do I find R? Exactly 3. Good. So do I have to do like 3, 4, 5, 6, 7? No, exactly is just the one calculation. Perfect. Good. Alright, what else you guys got?
We do like I get how to take like simultaneously. Like sometimes you put like multiples, multiplying it.
Oh yes, okay.
Division or
Yep. Alright. You'll probably get one of those.
Can we do just like one of the word problems, like the first question?
you add chicken.
Oh yes, like yes, wait. Okay. Yes. You're so funny.
I think I get no more money. Do you like tomatoes? Wait, if you like tomatoes, you get more. How much do I? Yeah. Guys, so much money.
Yeah, I was 700.
Do you want to? Hey, freaking don't give Adam like 10 minutes. He owes me 10 minutes. Yeah, what time should we go tonight? What time should I go?
Go before. Do you like tomatoes in there? No.
Yeah.
Do you want tomatoes or can I just say? Are you guys?
Ab, can I make it up?
Yeah. Do you like tomatoes in there?
Okay, so if I give you, alright, there are 10 teachers and 6 students. How many ways can I choose? Yes, yeah, I choose. Stand, you can walk around if you want to. How many ways can you form groups of 3 teachers and 2 students?
Would this be the multiplying one?
Wait, I don't know what to do. I don't understand how I did so bad at the beginning of the year.
If you're never going to do a plus or a minus, that's like next
Always gonna be multiplying equals next year is a different story.
Why? What would be like a plus?
That's like conditional probability and like weird like 2-way tables and stuff.
That sounds
You do
awful.
like 10 categories and 62 and then multiply.
Yeah, we do that.
Didn't you say the other day that if it was a division, it has to say probability?
Right, it'll say like find the probability
And
of
that's
it.
as.
Right.
Okay.
So this one, you want to group us together, times 3 times. You have 6 students, you want to choose 2 of them. 6, easy.
What if you got like, alright, now I have a question.
Can you plug it in like that?
Yeah.
What are the chances that the probability will be on the test?
You're going to get one question just like this.
Yeah.
I don't know what is like wrong with it, but I don't know what to do. Like,
I need to get back to you. When do you need to divide?
If it says something like find the probability of someone forming a group of like, and it has to say in here find the probability. And then you have to put like the total over what you want. So like your total number of people here would be 16 being 5. Cause like there's, and then you're taking 5 total.
You put what you want on top and then you put the
Total. Right, and that's what probability is, right? Like what you want over the total. This would be probability. If it just says like how many, you're not trying to do probability, there's no fraction sign. You know, I don't know. Like you gotta group it together. And do you get the idea of like the order of importance and not important? You did so good when you had them on that paper.
Yeah, I got it that one day.
No, do top and bottom. Anything that was, if you put the division symbol like this, it thinks to do this first and then multiply for some reason. It's all messed up. Okay. Somebody asked me. Oh,
I did. Yeah. What are you doing?
All right.
The word problem is the one where it's like there's 18 C's and increases by like 2. I have to add them all up because I don't know what.
Do you want to do one of those?
It takes me forever.
Do you want to?
No.
Whenever I do the try to do the problem because I know it, but I always get it wrong. I don't know. What is
Do you see anything on, oh, analysis of data is probably the. Yeah, just for this one.
Wait. Oh, I would not be doing that.
Okay, let's look at these. Let's start with number 2. They're easy, you gotta get them right.
Oh shit, I'm not sugar, sorry. What's the difference between a census and a doesn't census like count people like the household survey? But isn't a number of each doing a survey like the same?
I would say observation is like what you see, like what you observe.
Yeah, you're not doing any kind of interaction. It's kind of just like survey, yeah.
Alright, what's the census?
Census is like what the government gives to every single person to see like how many people live in your house, like how much money you make, like
How you figure out the population is
the age of everyone living there. Okay, what about 3? This is a good one. Yeah.
Sorry,
That's okay. Alright, good. Choice 4. What's your clue with choice 4? 2 groups. Good job. 2 groups. 2 groups. Anything else? You're good, Jessica? You got this. Hopefully I got this.
Have a good night.
Thanks. You too.
See you tomorrow.
See you in the morning. What else do you guys think? Are we good with law sign, law code sign, like setting them up?
And take any advanced tomorrow.
Right, Frida. You'll be fine.
Oh, yellow. Yeah, go for it.
Now,
Somebody call her. Just suppose I'm in lobby.
Okay, so I would go from 5 to 3. What was that? 8 have to be? Okay, good, so it has to be 8, right?
They don't want your phone.
Oh.
Good job, you're doing well.
You okay today? You're okay today? Like, you with it?
Oh, trig?
Yeah.
No.
Don't freak yourself out. Like, you know more than you think you do. You're gonna be okay.
That's what I'm on my mobile, and then I went in and I blanked on everything. It didn't go well, so.
Oh no. Right, so read it in order. Unless it goes as it's gonna need to be.
Okay, so D will care.
Yep, it's always like the order.
So there's no intervals in it like that?
Yeah. It'll be like
So just don't.
R, T, you know, weird things. Usually they don't do X, Y.
For each time, like, and then they give you another number to put.
Yeah, it's always the same. Do you have anything else? We've got recording.